And Pontus could not join us today, but Ralph McNutt thankfully stepped in to tell us about the interstellar probe, future exploration of the outer solar system, Kuiper Belt, heliosphere, and beyond.
Thank you. So yes, so I'm Pontus for the day. So of course this is a study that we did. Pontus was the scientist on it. I was the troublemaker that brought the money in. And we had a large team of people, not only at APL, but also throughout the entire world that actually helped with this. So a lot of you have probably seen a lot of this before, but I will go back through and basically review it and make some comments about where we are now. Wanted to start out and just say that, New Horizons really is the fifth interstellar probe. It's just that none of the five are planned as such. These were all planetary missions that just kept on going. Uh, Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. And the reason that they kept on going is because they had RTGs on board. And just like the Energizer Bunny, they just kept going and going. And of course, Voyager right now is coming up. The Voyager 1 and 2 are coming up on 50 years. The Voyager 1 launch have been 50 years ago on the 5th of September 2027, and I got to watch the launch as a graduate student at the Cape. So we'll see if I make it to that date as well. But you can keep these things going. You do need the RTGs, and we said a little bit about that earlier, and that's a different long topic. As far as an interstellar probe, a dedicated mission is concerned, there have been past dedicated concepts that were very far ranging. They all had several things in common and they all had a common problem. They were all big, they were all powered with nuclear reactors, they were incredibly expensive, except nobody bothered actually trying to estimate a cost. They all used non-existence technology, and none of them have ever flown. As a matter of fact, this concept right here, this was from a JPL study that was done in 1978 to 1980, and with a fission reactor. And the big thing was the interstellar probe, and the little probe on the bottom was the Pluto flyby mission that was going to be dropped off in the year 2000 when they flew by with interstellar probe. So what goes around comes around. This is the actual study. We were actually funded by the Heliophysics Division at NASA in 2018. The study ran through mid 2022, and again, we had a lot of people. I think there were 30 countries involved, along with probably about around 400 people total. There were the primary authors of the report. There were about 140 of us. This is out online at www.interstellarprobe.jhuapl.edu. It's 498 pages long. There are also variations of this that are published in the literature, especially in the journal Acta Astronautica. And also on the website, there are a lot of tutorials about the mission as well. Now, this was pitched to the Solar and Space Physics Decadal Survey in 2023. And as such, the main goals, because they were the ones that funded the study, was really to looking at our habitable astrosphere and its home in the galaxy. And so this was really focused on fields and particles. We were looking at three different main science questions that all had to do with the heliosphere, all had to do with the solar wind, and how all that goes together, building upon the things that we learned from the Voyagers and are still learning from New Horizons right now about what if we had other instrumentation we could do a better job with. And basically the study, which is in one slide here, there were traceability matrices that were started with up on the upper left. That fed into payloads, that fed into engineering studies. There were actually 18 previous studies of this concept that had been done before. Starting in 1958. So this was really drawing upon those. We put in a technology horizon that this thing had to be flyable by 2030 without any miracles other than having a launch vehicle that was appropriate, would be ready, which is why we also picked on an SLS Block 2. And the baseline mission characteristics were for 50 years of flight. We would turn over the flight crew once every solar cycle, every 11 years. And so, and keep paying it forward. And that's the way that you run the mission. And again, Alan mentioned that this has really been pioneered and worked very well with changing over your flight crew to a very large extent on a regular basis. We actually looked at implementation schedule cost, and we looked at the cost very closely. We got into a little bit of an argument with the people that ran the decadal survey. I think we did a better job on cost estimation than they did. But nonetheless, this would be an expensive mission. This is something like about $1.4 billion before you throw in the launch vehicle and before you throw in the RTGs. About what solar probe cost, Parker Solar Probe, if you put in the inflation factors. And then we were talking about running this thing for 50 years as really the prime mission. Well, at about $22 to $25 million per year to have a robust science plan, 50 years gives you a lot of money. So one of the things that this was criticized for was how much that it was going to cost. But we thought that it was important to actually put some honesty out front about if you were going to do this and really try to go as far and as fast as you possibly could, which has always been the idea. Then you needed to be honest about the cost as well. We looked at D-scopes, we looked at up-scopes. Basically, this is following the philosophy that was in the Powering Science National Academies report that came out a few years ago about looking at large strategic missions and their place within NASA and within the U.S. space program. Basically, the idea would be to launch by about 2036. 50 years takes you out to 2087. And an extended mission could get you out to the year 2104, perhaps, when Pluto is at its next aphelion from the sun. The decadal survey came back and said, well, this is too expensive. Besides, we're going to do heliophysics nearer to the Earth. But there was a recommendation in that report that the Science Mission Directorate, because of course they're another source of money, should develop a cross-divisional approach to specifically support development of a mission to interstellar space. Because one of the things that we looked at was, well, what other cross-divisional things could we do, including planetary science and astrophysics as well? And of course, if you've got the platform, there are a lot of things you can do. It's a question of choosing instruments and choosing the science team that you use. Now, New Horizons, primary science. Well, we got by Pluto and we got by a Kuiper Belt object. We check that box off. But in checking that box, as the previous speakers have noted, we have learned more about the diversity and about all of the incredible things that there are still to be learned out there. And so an interstellar probe is something that could be sent by another one of the another Kuiper Belt object, for example, on the way out. New Horizons, we're talking about a possible second Kuiper Belt, more dust, again, things that we didn't have as good of an insight on the Voyager measurements. We've got a much better insight now with New Horizons, and we've got some ideas about what we should do as a next step. And the next step could be on a mission like this. Right now, we're looking at New Horizons as being, and where we might cross the termination shock or the solar wind based upon what we were able to find from the Voyagers. And this mission would be something that with a very large rocket and about the same size as the Voyager spacecraft. This is, I think our baseline was about 860 kilograms with fuel. Voyager was at about 725 kilograms. And basically this would fly twice as fast out of the solar system as New Horizons, twice as fast. Alan's fond of talking about after the launch of New Horizons, we got past lunar orbit in 9.5 hours. This would take that down to 6 hours during the launch. And yes, we've actually looked at what you could do with a Starship, assuming that one could launch one without it blowing up, which is a different problem. If one of them worked according to specs and we could have one of those, you could get up to about 10 AU per year out of the solar system. This would get you out of the solar system at about 5 AU per year, and a Falcon Heavy at about, this would be about 7 AU per year, and a Falcon Heavy about 5 AU per year. So the idea of going back and looking at cross-divisional goals, again, I mean, the science has not changed from looking at all of these 18 previous missions. It's just been refined better as we've gone, but it really is, there's a heliophysics part that's all about really understanding our habitable astrosphere, its home in the galaxy, and now how that this would link up with what we're seeing with exoplanets. These other goals would be, again, dwarf planets and KBOs. Kirby Runyon actually was one of the big contributors on this study. And Kirby, you're out there somewhere, I know. You're up there. So anyway, Kirby's the one that figured out that, yes, if I need to do a Jupiter gravity assist, that's fine. That gives me a one launch opportunity every 13 months. And depending on which one that you want to take, I can go by another KBO. It'd be like a Pluto flyby. We're not going to slow down and go into orbit because we're trying to get out fast. We can look at the circumstellar dust disk. We can look at extragalactic background light. Again, largely being informed by what we have learned with New Horizons. We can tweak our instruments, we can use newer instruments, and we can add on to what we're currently learning with New Horizons and take the next step forward. So, again, this has been a long-standing vision. Actually, there was a report that was out by what was in the Space Science Board of the National Academies, 1958, mentioned that there were three missions that ought to be done. One, a mission perpendicular to the plane of the ecliptic, now known as Ulysses. One, a probe as close as possible to the sun. Parker Solar Probe got launched in 2018. And finally, a mission away from the sun going as fast as possible and as far as possible. And that's what this would be. And, Alan talked again the other day about how hard it was to keep, and Glenn as well, about how hard it was to keep New Horizons on track. And you basically have to take heed from Tennyson's poem, Ulysses, that this is all about striving, seeking, and finding and not yielding as we continue to go forward. So Interstellar Probe, the reports are out there, and you can take a look at it. 498 pages, or you can print a copy of it and use it as a doorstop. And we looked at all of the pieces. Looked at where Voyager 1 was, Voyager 2, now New Horizons, an interstellar probe that would get us out and keep operating at least out to several hundred astronomical units farther than anything before, and teach us more and more about what's out there. So we didn't get into this past year's heliophysics decadal, but that doesn't mean it's not a bad idea in the same way that we had all the fights about New Horizons. So the quest continues. And I'm here to pay this forward to the next generation because we still need to do this mission. Thank you. 26 seconds for questions.
Oh, actually, yeah, that was the quote unquote talk time. So you did good.
Oh, excellent. If we
thank
get any
you for
questions.
Also very thorough overview. Good to hear the history and the future. I like the future looking aspect.
Well, I'm getting old. I got to be looking to the future to somebody else.
I see a couple people. Yeah. Coming up to the mic here.
Thank you for that wonderful summary for this exciting mission. Can you give us an idea what the payload would be, what we would actually take past a KBO and use to sense it, if you will?
Well, with a little bit of luck, Casey, I might actually remember better what page number that it was located on. We basically went through and we looked at all of the instruments that have been flown on all of the various missions, on Voyager, on Galileo, on Cassini, on New Horizons. Alice Kokoros here at APL was the one that took a look at that because we looked at characteristics. We looked at what these things actually had cost, what future versions might cost. And I think, basically we put together a pretty good payload. Pontus is the one you need to be talking to about this, but the most important thing in all of this was that we got together a huge number of people, and by God, we hammered out a consensus amongst everybody. And that was the most important exercise, I think, out of the entire part of the study.
Well, I'll help you a little bit then. There's the plasma and particle suite. There was also, on the augmented, there was an infrared mapping spectrometer. And I believe, Kirby, you had a camera?
Yeah.
And which maybe you can mention very quickly what the camera would do.
Well, thanks, Casey, for setting up my question.
Yes,
And-
well, thank you both, because these are the guys that were worried about that stuff. I was worried about how fast we could get out of the solar system.
Yeah, well, this is kind of like getting the band back together with Casey here and everything. Yeah, so I was just curious if there's any update on a preference of spin stabilized versus 3-axis, and or if it is a spin stabilized spacecraft, what the implications are for going 3-axis temporarily, and then if you have a spin camera that can take advantage of spacecraft spin, all those questions as it relates to imaging KBOs.
So, well, we haven't gone back and looked at that. And so, of course, we know what we can do with a camera on a spin stabilized spacecraft, because we did that on Pioneer 10 and 11, and you can do it, but it's not the easiest and best thing to do. And so again, we've learned from New Horizons that if I have a dual mode spacecraft where that I can slow down and hopefully not break the magnetometer boom off, which is a different problem if I've got a mag boom on this thing. I would like to be able to fly by targets, Kuiper Belt objects on the way out, or targets of interest in a 3-axis mode. And the rest of the time, I would like to be spin stabilized because I'll use less fuel, and I'll also be able to scan the sky for particles. So this is another one of those things that we had a great deal of discussion about. And, basically what's going to happen if you go to a dual mode, it's going to cost you more money and it's going to cost you more fuel. But that's okay if that's the community that is going to be the ones that are going to be helping to foot the bill. And this gets back to building a consensus. And again, that's why the 3-axis stabilized parts were relegated to appendices, because it was only the heliophysics division that was paying for this report. But we wanted to be sure that that option, if somebody from the planetary science division wanted to pick up part of the tab, that we had fully explored that part as well. So the answer is, I don't have anything else to give you. But other than to say that, it's all in the report, and we did look at both of the cases.
We are already 5 minutes into the break, but how strongly do you feel about your question? Do you want to just catch Ralph afterwards?
Well, I wasn't part of the discussion for Interstellar Probe, but from an astrophysics point of view, and certainly planetary, the last thing I want is a spinning camera that you have to take apart. So
Yes.
If you're going to do this and you want buy-in, you want to have a 3-axis stabilized thing for some of the observations.
Right. And one of the important things that actually came up earlier is about, there was this discussion about reaction wheels. Reaction wheels are a problem if you want them to last for 50 years. And so you could fly this like the Voyagers, where that you have a 3-axis stabilized spacecraft, but you're going to need to use rocket jets in order to do the pointing and the stabilization. But it's certainly doable. And again, it gets back to exactly, who the group is that wants to get together and do this, because some things are mutually exclusive, and it gets back to, it really taking a village and seeing what the villagers all want to do for doing this mission. But to convince everybody that the mission is worth doing in some form or other.